Hello, and welcome to this presentation, Getting Started with NGT Power Supplies. This presentation will take you step by step through both basic and advanced features on Rohde Schwarz NGT series DC power supplies. This presentation assumes a basic familiarity with DC power supplies. If you're new to power supplies, or if you'd like a brief review, you might want to watch the presentation Understanding Benchtop Power Supplies before beginning this presentation. The Rohde Schwarz NGT is a family of high-power, rack-mountable DC power supplies, available as two different models. The NGT 3620-1 is a single-channel supply with a maximum output of 1800 watts, and the NGT 3620-2 is a two-channel model with a maximum output of 3600 watts, that is, 1800 watts per channel. Both models have a maximum output voltage of 80 volts and a maximum output current of 50 amps per channel. The NGT is easy to operate via its front panel touchscreen interface, but can also be remotely controlled. It also has a variety of advanced functions, and its channel fusion and multi-device capabilities enable even higher output powers and currents. In the remainder of this presentation, we'll walk through how to configure the most important functions and features of NGT series power supplies. Let's start by looking at the front panel of a two-channel NGT 3622. As mentioned a few moments ago, the NGT has a front panel touchscreen for easy configuration and monitoring. The Home, Setting, and User menu control keys provide quick access to frequently used features, and the output control buttons are used to selectively enable and disable channels. Below these are a rotary knob and buttons for menu navigation, and the NGT also has a front panel USB interface that can be used to connect a mass storage device for file transfer. Next, let's look at the rear panel of a two-channel NGT. The AC mains input is on the right, and a ground connector is located on the left. For each channel, there are three connectors: the DC power output connector, a connector for attaching sense leads, and the share bus connector. We'll discuss all of these shortly. Note that in most cases, terminal blocks are used for all connections, and appropriate wire gauges should be chosen based on the expected current levels. There's also a digital input-output interface for triggering and/or interfacing with external devices, and both LAN and USB interfaces are provided for remote control. Be sure not to confuse the LAN interface with the pair of multi-device interfaces to their left. These are used when combining multiple NGTs together. With regards to the AC mains supply, the NGT can operate on input voltages from 100 to 240 volts AC, with a tolerance of plus or minus 10%, and at either 50 or 60 Hz. These are sensed automatically and require no user intervention. Note that full output power on both channels does require an AC main supply of at least 200 volts, and a warning message will be displayed during startup if the NGT's maximum output power is limited by the AC mains voltage. Note too that the supplied AC mains cable comes with a special cable cover assembly that can be attached to the rear panel for safety. The use of an external AC mains disconnect switch is highly recommended instead of using the power cable itself as a disconnect device. Basic NGT configuration is very straightforward. To enter voltage and current for a channel, start by pressing the Home button. The values for voltage and for current limit can be entered either using the touchscreen or by using the rotary knob. Values can be confirmed either by pressing the checkmark key or by pressing Enter. Once voltage and current values have been configured, the channel buttons are used to enable channels individually, and the output button is used to turn on all enabled channels. Channel keys are backlit with different colors to indicate their operating mode. Green means constant voltage, and red means constant current. We'll come back to this topic in just a few moments. The default display of a dual-channel NGT shows both channels simultaneously, but clicking on a channel can be used to view it in larger or expanded format. In expanded view, statistics in the form of min, max, and average values for power, voltage, and current, as well as the total energy consumption in watt-hours, are shown on the right. Stats can be reset and restarted by clicking on the stats counter. To return to the collapsed view, use the collapse soft key or the back hard key. The NGT displays the output voltage, output current, and output power updated in real time. For each channel, configured values are shown in boxes, and the measured or readback values are shown above them. The color of the displayed values indicates the operating mode for each channel. Values in green indicate the channel is operating in constant voltage mode, and values in red indicate constant current mode. White indicates editing mode, that is, when the output is disabled. Let's pause for a moment and explain what we mean by constant voltage and constant current. Normally, the user of a power supply configures a fixed output voltage. In this case, the output current depends on the load resistance, as per Ohm's law. This is called constant voltage mode because the supply will hold the voltage constant, even if the load resistance, and therefore the current, change. Note that if the load resistance decreases, the amount of current supplied will increase. A large drop in load resistance could therefore lead to current that's high enough to cause damage. One solution to this problem is an electronic fuse that turns off power when maximum current is reached. Instead of disabling the output entirely, another solution is to limit the current to the maximum value by decreasing the output voltage. In this case, the supply is said to be operating in constant current mode. Whether a power supply operates in constant voltage or constant current mode is determined by the user-specified output current limit. There's no button or menu to toggle between these two modes. Let's look at an example of this on the NGT. We configure the output voltage to be 2 volts and enter a current of 400 milliamps. After enabling the output, the NGT will hold the output voltage steady or constant at 2 volts, even if the current changes, as long as the current remains below the configured current threshold of 400 milliamps. Since we're in constant voltage mode, the values of voltage and current are displayed in green. Now let's decrease the current value from 400 milliamps to 300 milliamps. The output voltage still starts out at 2 volts and remains constant when output current changes, but only as long as the limit of 300 milliamps is not exceeded. If, however, more than 300 milliamps would be drawn, the NGT automatically switches to constant current mode and lowers the output voltage until the output current does not exceed the configured current limit. When operating in constant current mode, values of voltage and current are displayed in red. Although power supplies are usually operated in constant voltage mode to provide a fixed voltage, there are cases when we may want to have an output voltage that dynamically changes based on a user-defined pattern or sequence. The NGT supports 2 different functions for dynamically changing the output voltage, namely ramp and arbitrary. Let's take a closer look at both of these. As the name implies, ramp is used to create a continuous rise or ramp in output voltage. The output voltage starts at 0 and then rises to a defined voltage over a ramping time from 10 milliseconds to 10 seconds, with a configurable step size of 1 millisecond. At the end of the ramp, the output voltage remains constant at the final ramp voltage. Ramp settings are configured on a per-channel basis under ramp. The ramp time must then be entered. Recall that this is the time needed to go from 0 volts to the configured output voltage. When a ramp is active, a special ramp icon will appear in the channel display. Unlike ramp, which linearly increases voltage from 0 to a defined value, arbitrary switches the NGT output between different discrete voltage levels or current thresholds. Each one of these levels has a user-defined value and duration, and the sequence can be repeated indefinitely or a fixed number of times. Like ramp, the arbitrary function is enabled per channel from the channel menu. The points in an arbitrary waveform are defined using a CSV file, where each line contains an index, voltage value, current value, duration, and interpolation. That is, whether values are interpolated between points. This CSV file can be loaded from internal memory or from an attached USB drive. And as with ramp, a small icon will be displayed in the channel menu when Arbitrary is active. As mentioned earlier, the sequence of points in an arbitrary waveform can be generated continuously or for a user-defined number of repetitions. Note that setting the number of repetitions to 0 means the sequence will be repeated continuously. The other configurable behavior is the end behavior. Here, the choice is between disabling the output at the end of a sequence or holding the output at the final voltage or current value. The next topic is protection functions. These are used to protect the attached load from excessive voltage, current, or power by disabling the output when a user-defined threshold is crossed. Protection functions are configured under the channel menu and are enabled or disabled independently for each channel. Both overvoltage and overpower protection are activated when a user-defined voltage or power threshold is crossed. As with other forms of protection, the channel is turned off when protection is activated, and output has to be manually restarted. Visual indications in the form of blinking icons appear in the channel display when either an overvoltage or overpower protection has been activated. Overcurrent protection, also called an electronic fuse, is activated when current drawn by the load exceeds a threshold. Note that unlike overvoltage and overpower, the current limit is not entered in the protection menu, but is taken from the main voltage and current settings. As before, if protection is activated, the channel is turned off and must be manually restarted. There are two delay parameters associated with an electronic fuse or overcurrent protection. Fuse delay time is the time between when the overcurrent threshold is crossed and when the output is deactivated. Fuse delay at output on is the amount of time the NGT will wait after power on before applying the fuse. This can be used to prevent the fuse from being activated by high inrush currents. Fuses can also be linked to the second channel in a dual-channel unit. In this case, if overcurrent protection is activated on one channel, both channels are disabled. And like overvoltage and overpower, a blinking icon in the channel display indicates that overcurrent protection has been activated. Safety limits are another type of protection that limits the configurable range of output voltage and/or current. Safety limits prevent the user from being able to configure or enter values outside of a defined range. They don't disable output like other protection functions discussed earlier, but an audible alert is sounded whenever a user tries to configure a value that is outside of these limits. Safety limits are configured and enabled per channel in the form of maximum and minimum values of voltage and current. Now that we've covered the most basic functions of the NGT, let's look at some of the more advanced functions. These include output delay, remote sense, data logging, digital input and output, channel fusion, and sync mode. We'll start with output delay. Normally, voltage is present at the output immediately when output is enabled. However, the NGT also allows you to configure a delay between when the output is enabled and when voltage is present at the output terminals. During this delay, the channel key will blink and only become solid when output begins. Next, let's talk about remote sense. The cables connected to a power supply's outputs have resistance, and this will cause a voltage drop between the power supply and the load. In many cases, this very small drop can be ignored, but it can become significant with high currents or small load resistances. Remote sense is a method used to monitor and compensate for the voltage drop in the supply leads. In remote sense, two leads carry the current as normal, but two additional sense leads are used to measure the voltage at the load. Because these sense leads are connected to a very high impedance in the supply, there's almost no current flow in these leads, and therefore almost no voltage drop. Based on the readings made using these sense leads, the supply can adjust the output to obtain the desired voltage at the load. On the NGT, remote sensing is configured in each channel menu under Output Remote Sensing. The default mode is Internal, which simply means that Remote Sense is disabled. To enable Remote Sense, the mode must be set to External. In this case, the sense leads must be attached before output is enabled in order to prevent overvoltage or unregulated output. This is especially important for lower voltages. The sense lead connections are on the rear of the NGT, and a small icon will appear above a channel when remote sensing is being used. Our next topic is logging. On the NGT, the measured or readback values of voltage, current, and power can be logged to a CSV or comma-separated value file for export and analysis. Logging is configured globally for all channels under Device Logging. The logging interval and duration or mode are configurable, and the log data can be stored either on a USB stick or to internal storage. To turn logging on and off, simply enable logging under the Logging menu. The NGT has 8 independent digital I/O lines on the rear panel, and these are configured under Device Digital I/O. These lines can be used either as input or output triggers for interacting with external devices. For example, they can be used to signal various types of events, such as when output is enabled, constant voltage versus constant current mode, protection events, etc. Configurable parameters include the signal direction, the associated condition or event, the level, channel, etc. In the interest of time, we won't go into detail on digital I/O in this presentation, so please see the NGT documentation for more details on how to configure and use this feature. In a dual-channel NGT, the two channels can be combined or fused in 2 different ways. One is using them together in parallel to provide higher current, and the other is using them in series to provide higher voltage. This channel fusion mode is configured under the Channel tab. Note that the Channel Fusion configuration dialog shows the maximum values of voltage and current for the fused channels, as well as a connection or wiring diagram. When channel fusion is enabled, the main display of the NGT will show the fused values, that is, the combined values of both channels. The fused channel state, series or parallel, is shown as well. One of the advantages of using channel fusion is that the voltage and current values can be directly entered for the fused channels, rather than entering them individually or per channel. For example, here we can enter a combined voltage of 160 volts instead of entering 80 volts for each channel separately. One thing to note is that in parallel mode, which is used to obtain higher currents, the share bus connectors on the rear of the NGT can be used to help ensure equal current sharing. A pop-up message will prompt for this connection whenever parallel mode is initially selected. In addition to sourcing current, the NGT also has the ability to sync current. This is configured by changing output mode to sync in the output menu for a given channel. Note that the default channel behavior is source. When sync mode is enabled, this is shown using negative current values for configuration and display. Here we see the NGT syncing approximately 1 amp of current. It's important to remember that the maximum sync or input current, 2.5 amps, is significantly lower than the maximum output current. Let's end with a brief summary. The NGT is a family of high-power DC power supplies that's available in both single and dual-channel models. The NGT is easily configurable via the touchscreen and front panel controls, but can also be remotely or programmatically controlled. Some of the features of the NGT we've covered in this presentation include ramp and arbitrary output, different types of protection functions, remote sense, data logging, digital I/O, channel fusion, and current sync. This concludes our presentation, getting started with Rohde Schwarz NGT power supplies. If you'd like to learn more about power supplies or power supplies from Rohde & Schwarz, please see the links in the video description. Thanks for watching. Please subscribe to our YouTube channel and visit us at rohde-schwarz.com.